All right, so this video is going to talk about the area of triangles. And in order to think about the area of a triangle, we are actually going to think about the area of a parallelogram. And so when we look at this parallelogram, it's not my best drawing of a parallelogram, but we can see that if we were to split our parallelogram into half, one thing we know is that it would create two equal triangles, two triangles that would be congruent by side, 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 right? So we know that those two triangles, if they're totally congruent, they'd have the same area. So we can really think about the area of a triangle as half of the area of a parallelogram. So we take that area of the parallelogram, base times height, and we divide it by 2. Now, it's important to remember that when we think about the height of a parallelogram, we are thinking about this perpendicular height. So if I were to drop a altitude, right, and I think about that, this is our height of that triangle. It is not one of the sides of that triangle necessarily. And when I think about the base of that triangle or the base of our parallelogram, that is the base right there. So it's really important when you're thinking about triangles to not always think about the height as being a side in the triangle. Like in this triangle, we can see the height is not one of those 3 sides. So when I take a look at, there are 3 triangles that you might see or think about. One of them is our traditional right triangle. You've probably thought about that one a lot in your life. When we think about that, that's the easiest one to think about because we have our base and we have our height. So our area is half of that base times height. However, in reality, most of our triangles are not always going to be right triangles like that. So we could think about taking a triangle, dropping the altitude so that it is perpendicular. Our base is this entire base of the triangle, whereas the height is the perpendicular height, right, that altitude. Or the last option is we might have a triangle that looks something like this. And when we look at this triangle, let's say we use this side of our triangle as our base, well then our height has to be the perpendicular to that. So we have to extend it outside of that triangle to be able to see what that height is. And we did this with altitudes when we were studying triangles in first semester. So that area of our triangle is this base times height over 2 because it's half of the parallelogram. Now, let's talk about how we could use this to help us. So this says we know a side measures 16 centimeters. It doesn't tell us which side, but we see that it is equilateral because of the markings. So I can actually label all 3 sides as 16. And we want to find the exact area of the triangle. So I'm going to start out by writing out base times height over 2. Let's say that I make this my base. People always like to make the base the thing that would lay across the ground. It doesn't have to be. We could do it in any way, but that's usually the easiest way for people to visualize. So my base is going to be 16, but I don't know what my height is yet. That height is not 16 because I have to think about the perpendicular height. What would happen if this were the altitude drawn in like this? Now, there would really be 2 ways to approach this. One of the things we know about an equilateral triangle is that all 3 angles are 60, which makes these 2 separate triangles both 30, 60, 90 triangles. So that's one method. Another method is you might split this into half, 8 and 8, and do Pythagorean Theorem. It's really up to you which way you prefer to do it. Let's say I do 30, 60, 90, 1 root 3, 2. My hypotenuse, which is across from 90, is 16. And what I really want to know is this height, which is across from 60. So I get my ratio that looks like this, and I'm going to cross multiply. 16 times root 3 equals 2 times h. And I'm going to divide both sides by 2. So now I see that my height is 8 root 3. So I can go back up to where I had started filling in my formula and put 8 root 3 for the height. Because it asked for the exact area, I want to make sure that I leave this in terms of the root 3. So I can figure out what is this, 16 times 8 over 2, which is going to be 64. So 64 root 3. And then I have to make sure I know what, since we're talking about area, we're talking about square units. So we're talking about centimeters squared. So again, none of this is really a brand new idea for us, but we are bringing in all of the previous knowledge we have that helps us be able to tackle new problems because of our right triangle trig. I think we are going to look at 2 more problems. Yeah, that's right. So let's take a look at this one. This one says the hypotenuse measures 17 centimeters. So that's this side right here. And a leg measures 8 centimeters. And we don't know which leg it is, but for the sake of the drawing, I'm going to go ahead and label one of my legs. And we want to determine the exact area of our triangle. And when I'm looking at this, I'm thinking about our triple, 8, 15, 17. So I know my third side is 15. Now I could have also done Pythagorean Theorem. When I do this, I'm looking at, again, that base times height over 2. When I look at the base, I could use the base of 17, but then I have to drop a perpendicular line right here, and that means I'm now solving for that height, which I don't really want to do, when I already have a base that I could use that would be already perpendicular to one of the sides. So I'm going to use these 2 sides. I'm going to use 8 as my base and 15 as my height because they're already perpendicular. Then I don't need to drop any altitudes. And so if I do it that way, I can get 60, which is centimeters squared. So make use of what you have. Your base may not be the thing that's lying across the ground. You could do it that way, but you might be making your life a little bit harder. Okay, and one last problem that we're going to take a look at. So this one says that we're given a triangle where the area is 48 centimeters squared. So I'm going to already put in my area formula for a triangle, and I'm going to put 48 in for area. And it says the base measures 12 centimeters, so I'm going to put that in for the base. And when I do that, I see that I actually can solve straight for the height, which is what it's asking for, without drawing a picture. Now, if I wanted to draw a picture, I could, and I could say, okay, well, the base is 12. We don't know what the height is, but we know the area is 48. You know, we could draw a picture to help us. So I'm going to go ahead and solve this. So I'm going to multiply both sides by 2. So I get 96 equals 12h. I'm going to divide both sides by 12. And when I do that, I'm going to get a height of 8. My units is going to be centimeters because we are talking about length. So that's a video all about the area of a triangle. I want you to keep noticing how our prior knowledge, Pythagorean triples, 30, 60, 90s, right triangle trig, it's all going to keep coming up. So this is another plug that if you want a refresher on some right triangle trig, this would be a good time to do it.